Hey everyone, welcome back to the channel. So let's discuss the problem for today. Let me show you the problem statement. Before that, I'll just quickly check if we are live. Yes, we are. Okay, just a second. Fine. So let me show you the problem statement, which is from your greedy approach, minimize the heights. Okay, let me explain you the problem statement. So you are given an array denoting heights of n towers, okay, and a positive integer k. What you have to do is you are given an array in which you are given certain operation which you can perform on every element of the array. What is it? You must perform exactly one of the following operations exactly once for each tower. That is, either you can increase the height of each tower, any tower, by k, or you can decrease its height by k. You have to perform only one of the two operations on each tower. And why you have to do this? You need to find out the minimum possible difference between the height of the shortest and the tallest towers that you have. Let me take this test case, then I'll help you understand what are they trying to say. Okay, just a second. Okay, just let me just see. Okay, so for example, if I take this first test case, which is 1, 5, what we have here is 1, 5, 8 and 10. Okay, and tell me the k that is given to you is 2. That means you can increase or decrease just by this 2 units for any tower. Okay, let us see what we ultimately have to do. Our goal is to minimize what? Minimize the difference between the tallest and the shortest tower. So as of now, you see this is your shortest tower and this is your tallest tower, right? So right now, what is the difference? 9. Is there any way that we can minimize this difference? And the possibilities to do this is either we increase each tower's height by k, or we can decrease it. So what kind of operations on any tower will help us decrease this quantity? Let's see if we can do that. So as of now, I have 1, 5, 8, 10. Okay, if for example I increase the height of first tower by 2, what I get here is 3. Okay, in this case, now you tell me, if I increase this height and this 10, I cannot leave 10 as it is. I have to perform any of the two operations. If I increase its height, the difference will remain same. It was 9 previously, now also it will be 9. So why not I reduce its height? If I reduce its height, definitely I can decrease the difference between them. Because now if I reduce, minus 2. If I reduce its height by 2, that is by k, now the height of the tallest tower that I have is 8 and the smallest is 3. So 8 minus 3 is going to give me 5. That is for sure. Now you will say that we knew this was the sorted array. We knew this was the tallest tower, this was the shortest tower. I took a wise decision by increasing the height of the smallest tower by 2 units and decreasing I decreased, and there was the tallest tower was there. I decreased its height by 2 units. So somehow I managed to reduce the difference, and now any operation that I will perform for the towers in between them won't make any impact, right, on this difference. So you'll say, why not we just choose the smallest and the largest tower, and for smallest we can increase its height by k, and for largest we can reduce its height by k, and then the whatever difference we get is going to be the answer. No, that is not going to be the case for all the test cases. Why? For example, let's take randomly something. For example, if I take a case like this, first of all, you know one thing for sure, no matter what kind of an array you are given, you will sort it, right? Now for example, if I have a tower like this, okay, let me think of it. 3, 5, and I'm already writing it in sorted order, and then what I have is 5. Fine, and let's say 5 again, for example. Okay, let's see, I'm just creating it. Let me see if I can bring that kind of a test case to you. For example, right now what k I'm giving you is Let me make it. Four, 5. Okay. Right now the difference is 1. Okay, I can see, sorry, 5 minus 3 is 2. So I can see right now the difference between the tallest and the smallest tower is 2. Is there a possibility to minimize this difference? And I tell you, for example, your k is, let me take your k as 3, for example. If I take your k as 3, let us see if we can still minimize the height of this tower from 2 to something. So first thing that you have to make sure that any tower, whichever operation you perform, if you're reducing the height of the tower, it should not go negative, right? So let's say if I perform the same thing, 3 minus 3 becomes 0, and okay, sorry, I am increasing the height of this tower. What we were doing above, I'm just trying to replicate it and see if that's going to help us. So 3 plus 3 becomes 6. I am just adding that and its height will become 6, and reducing its height by 3, so it will become 2. Now you see the tallest tower is right now with me 6. You see that how the tables have turned. This was the one which was the smallest tower performing the same operation that I was doing, that is I just added k units, and in here I reduced k units. So on reducing, this becomes my smallest now, and this turns out to be largest one. And the difference between my largest tower and the smallest tower now is 4. So see, it did not help us. Rather, this has increased the difference, right? We were trying to minimize the difference, and here it has increased. So you can see that applying the same thing we did above is not going to help us for all the test cases. Got it? This is the reason we are not going to go ahead with this. We have to think of something in a better way, in an optimized way. So one thing, the brute force approach that you can perform is that, let's do one thing. We have 2 possibilities. We have 2 operations to perform on each tower. Let's try out all these 2 possibilities for each tower. Calculate the difference between the minimum and the maximum. So for example, I'll perform 2 operations on this, that is plus k, then minus k. Same thing I'll do for this, plus k, minus k, and for each pair then you are comparing and checking which is when is your minimum difference. But this will come out to be somewhere 2 to the power of n of time complexity. Getting this point? So this is not going to be your optimal approach. Like this is a brute force approach we can think of. So how can we do? So again, we are going to perform these operations, but see how we go of n time complexity. Let me show you. So what is our target? Our target is to check if we can minimize the difference by performing either of the 2 operations on each tower. So let's do one thing. Let's do the same thing for each tower. First of all, what I'm going to do is I am going to compute my difference right now. Let's say my difference is coming from what I'm trying to do. Right now my difference is coming from this largest tower and this minimum tower, right? 5 minus 3 is 2, for example. This is the difference I'm going to get right now. But let's take some minimum and maximum values. My minimum right now, let me take it as this value, ARR of 0 plus k. I'm just increasing it by k units and reducing it by k units. Let me perform this on other test case which your question is given to us. So with just 3, 9, 12, let me take this test case and perform the operation so that you can see on it clearly. So what are we going to do? Let me show you. We have 3, 9, 12, 16, 20. So my idea here is that first of all you calculate the difference. The difference right now that you have between the largest and the smallest one, which is 20 minus 3, right? So you got 17 as your difference right now. Correct? Okay. Now what I'm telling you, that you initialize your min value to this ARR of 0 plus k units. Why? And your maximum will be this value minus of k units. Why I'm saying so, you'll understand in a while. And the k for this test case given to you is 3. So k is 3. If I increase this value, my minimum becomes 6 and my maximum becomes 20 minus 3, 17. Correct? Okay. Right now my min is this, max is this. I can see that my min value has not basically I have to also keep a check whenever I'm reducing the values. Any value that I'm reducing, it should not be less than 0. Okay, in that case I should not go ahead. Second thing is, you can see I am updating my min by increasing the value of this. Why? Now I'm taking the approach that I was using in the first test case, but I have to make this thing possible for all the towers that we have. Only then we can see if we are minimizing the difference to what percent, means to what value are we minimizing it. We'll do the same thing, plus and minus k on all the towers. See, now what I'm going to do, I am going to take a for loop starting from I equal to 1 and I will be less than n, right? In this, now I am going to update, let's say I take some other mi, min value 0, and ma, that is also 0. What I'm going to do here now is, see, wait, this is the loop. Okay, in this loop now, I first of all I'll check ARR of I. Wherever I'm starting my iteration from here, I have to check if this ARR of I, I'm trying to reduce, if I'm reducing it. Okay, if it is less than 0, just continue. What thing I'm doing now, I'm going to update my min. There is an answer. My answer will be initialized to the absolute difference between 20 and 3 initially, which was what this difference that I have taken here. You can take it as your answer, which you will finally return, right? So answer is 17 right now. Okay, fine. Now your minimum will be math.min of. Math.min of what? See, when I am at ARR of I, what I'm trying to do, I am trying to take each tower in pairs. So if I'm here, I am going to compare these two towers. This is the bigger one because I am in a sorted array. So I will compare if I reduce ARR of I by k and if I increase ARR of I minus 1 by k, right? In that case, which one is still the minimum? That should be stored with mi. Getting my point? So mi will be storing math.min of what was your minimum. This was your minimum previously. See, right now your minimum is standing at ARR of 0 plus k, the value that you got from here. So mi will be calculating the subsequent minimum of this min value which you got from here in the first case, and the value that you will be evaluating on ARR of I. This is minus k. Why? This is the bigger one. This is the bigger one. I am reducing it by k, and I will see which one is still storing its minimum value. That will be stored in mi, and ma will be storing the max value, math.max, on the same pair. What I am trying to achieve is, whatever you got in max, is it still my maximum value if in my ARR of I minus 1 I increase the value by k units? Got my point? If I increase, because see, I will here now in big O of n time complexity, we are again doing the same thing. We are trying to, on every tower, we are performing two operations, one by reducing it and one by increasing it. And in whichever of the cases, what if it becomes minimum in first case and this maximum for the other case? So that will be stored by mi and ma. And finally your answer will be evaluated as the difference between ma and mi. At any subsequent step, what if the minimum, which was minimum for the first iteration, what if it becomes maximum for your next iteration? Your answer might differ, right? So this is the reason we are doing this thing. Let's do a quick dry run so that you can understand. Minimum initially was 6, maximum initially was 20 minus 3. Okay, that is 17. mi 0, ma 0. Answer 17. Okay, you are starting from I equal to 1. Check what is your mi. So mi will be min of ARR of I minus k. If you reduce 9 by 6, what are you going to get? 9 by, we have k as 3. So this value becomes 6. Okay, let me write it here. This value becomes 6 and your minimum is 6. So it doesn't change, your min still mi becomes 6. Okay, min of this min value and ARR of both are 6, so it will stay 6. Now checking for ma, max of your 17 is the max value and ARR of I minus 1 is this, and we are adding 3 to it, so this value becomes 6 and this is 17. So MA is going to be 17 in this case. Now your absolute difference of these means the difference between max and min is 17 minus 6, right? 11 is going to be your answer as of now. 11 is going to be your answer. So see, initially what we took 20 minus 3, which was 17, right? And in one iteration I have reduced it to 11. How? Ideally what would I have done is I have increased the height of this tower by 3 and reduced the height of this tower by 3. So this becomes 17 and this becomes 6. So 17 minus 6 is 11. So this answer has been stored by our ANS, right? I have to repeat the same procedure for all the subsequent towers in case what if any one of them just changes the game, right? That will be handled in the different kind of test cases. Here it is going to be simple one. Okay, fine. But let's do our dry run. In the second, now I have I here. Let's evaluate your MI. MI was what? 6, right? It will evaluate the minimum value. Minimum value is 6 as of now, and error of I 12 minus 3. So this is going to be 9. Okay, so 6 is still going to be your MI. And for max, let's check. 17 is still going to be your max value, right? This is going to stay, and error of I minus 1, that is 9 plus 3, that is going to be 12. Okay, 9 plus 3, 12. Max is going to, MA is going to be 17 only. Now in the next iteration, when my I is here, your min value is 6, but error of I 16 minus 3, it will become what? 13. Okay, so minimum MI will not be affected, it will stay 6, correct? Coming to MA, max value is 17 and error of I minus 1, which is 12 plus 3, you will make it 15. It is still not updating MA, it will stay 17. Coming on to next iteration, that is the last iteration. You are at this, min is 6, error of I, which is 20 minus 3, is going to be 17. Your min is not, MI is not going to get updated. Talking about MA, you have max value, which is 17, and error of I minus 1, which is 16, right? You add K to it. So when you add 3, this value will become 19. And now I can see that my MA can be updated, right? Because I have just increased its value by K. It has exceeded this max value. So my MA will become 19 now. Let's evaluate the difference. So far my answer was not getting updated. Why? Because my MA and MI was same, but now in this case 19 minus 6 is 13. But the thing is, answer when I am updating, I am keeping a check that answer should be math.min of MA minus MI and ANS. So I see earlier I have already gotten an answer which was less than 13. So I will not update it into my final answer, right? So that is all about this question. Let me now show you the code. Let's code it quickly. Whatever we discussed, I hope you understood this problem. Let me quickly code it for you guys. So let's sort the array first. Arrays.sort ARR. Okay. Int min, as I told you, will be ARR of 0 plus K. Int max will be ARR of n minus 1 minus K. Correct? Okay, this is going to be your max value. Int answer, initializing the answer with the max which you have taken, that is ARR of n minus 1 minus, basically not max, ARR of n minus 1, the actual last value in the sorted array, minus ARR of 0. That is going to be the answer that I am initializing with. Okay, now take int mi. You can take better names so that you don't get confused. Starting my iteration from okay, cool. If I'm keeping a check here, if in any case the tower that I'm operating on, ARR of I, right, and when I reduce it by K units, if this value goes negative, continue. Okay, don't evaluate it further, just continue. Then update your mi with math.min of ARR of I. Okay, reducing it with k, ARR of I minus k, and whatever you had in min, you will update mi accordingly, and ma will be updated with math.max of whatever you have in your max value and the just previous value ARR of I minus 1, increasing it by k units. Compare both of them, and that will be updated in your MA. Answer will be math dot, we want to minimize this difference, that will be math.min of answer and whatever value you're getting by MA minus MI. That's all. Let's check. If you made a mistake, we'll correct it. So that is all about this question, everyone. If you have any doubts, you can ask me. Fine. Let me check if you guys have any doubts. Now we are done with this question. Guys, was the font size too small for you all? Bigger, sorry, I did not see your comment before. Okay, I will definitely increase this font size. How much shall I do it? I think 110, 125 is fine. Yeah, font size was very small. Don't know why. Fine. Okay, then that was all, everyone. Let me know if you have any doubts. In the next class, we will do the next question. Fine. Okay. Fine then. Thank you, everyone, and bye bye. Take care.